Again, some tips for question number 6 of assignment 2. This is again from a problem from centrifugal pump. The velocity triangle you consider. The outer diameter of the impeller is given, that is D2 is equal to 40 centimeters, that is 0.4 meters, and the impeller width at outlet, that is also given. Remember, these are the impeller width and diameter at outlet. So B2 is equal to 0.5 centimeters, 0.05 meters, and the total head against which the pump is working, obviously that is the manometric head, so that is just 15 meters given. And the vane angle at outlet is phi. Angle made by VR2 with U2 is vane angle at outlet, so that angle is 40 degrees. And manometric efficiency eta mano, that is 0.75%, and we know that manometric efficiency is manometric head divided by the oiler head, HE. In fact, it is manometric power by impeller power or oiler power, rho GQ by rho GQ HE. It is HM by HE, and HE is HE oiler head. So oiler head is VW2U2 divided by G, since VW1 part is 0. So when you use this equation, and before that you find U2 is equal to pi D2N by 60, and here N RPM is given 800 RPM. So from D2 and N you get U2. So U2 is equal to so much meter per second. So once you get U2 and all, so you start from eta mano is equal to HM by HE, that is substitute for HE, so it will be GHM divided by BW2 U2, and HM is known 15 meters, U2 we just found out, and manometric efficiency is 0.75, and from this definitely you can get VW2. So VW2 is now available, and once VW2 is available, from the outlet velocity triangle, tan phi, find an expression for tan phi. So tan phi is the opposite side BF2 by adjacent side is U2 minus BW2. So from this obviously you can get BF2, because tan phi is 40 degree, U2 is known, BW2 is known, you get BF2. So from this, now the velocity of water leaving the vane, easily you can find out, and one answer we have found out already, that is velocity of flow at outlet. Velocity of flow at outlet you will get from this. And now the second part is velocity of water leaving the vane. Of course, it is absolute velocity, that is by using Pythagoras theorem from the outlet velocity triangle, that is VW2 square plus VF2 square. So once you find that, the second part of the answer is over. And the third part, once you have VW2, BF2 and the other parameters, you easily find out the discharge Q is equal to pi D2 B2 BF2. So BF2 D2 B2 is available, so you can find out Q, so much meter cube per second. And the fourth answer to the question is, what is the angle made by the absolute velocity at outlet with the direction of motion at outlet? Direction of motion at outlet means U2. So what is the angle made by V2 with the direction U2? So the angle is beta. So if you find tan beta from the outlet velocity triangle, it is VF2 divided by VW2. So easily you can from this you can easily find out what is